G'day and thanks, Simran. As explained, my name is Murray O'Keefe and I'm one of the mining superintendents for Whitehaven Coal at our flagship Maules Creek operation. Well, like everyone, I have many areas of responsibility, but realistically, this day and age, I'm mainly playing around with sort of analysis and improvement projects and looking after dispatch and the fleet management system, mainly from a people and processes perspective, not a technical perspective. We have been using Avoca in a serious fashion on site for a bit over 12 months now, and we've recently just committed to purchasing the product outright for a second year and using it long term. There's a few reasons for that, but there's a really succinct example that I'm going to go through. So I've just flipped the screen onto a haul cycle variability and shift details. So this is one of the first dashboards we created as a site with help of the Avoca team from within Wenco. So it's modelling by a dig unit, and the 5 dig units you can see there are our ultra-class Hitachi EX8000, so our big girls loading ultra-class haul trucks. And what that models on a per shift date is what the variation in the average haul cycle time is. So we use Wenco's dynamic dispatch, so trucks get flipped around between different dig units, but for cycles where a truck gets loaded, hauls to a dump, and returns to the same dig unit, you can see that if we look at June the 17th for 261, there's a 28.3% variation in that time that it's taken. Whereas you can see for, again, just looking at 261, the average is a lot closer to 11 or 12%, sometimes even better. So this dashboard's allowed us to pick out, outlier days or shifts. You'll notice there's 2 results for every day, obviously day shift, night shift. And if you look at that, again, I'll pick on that night shift from the 17th of June on 261. That allows myself and the other superintendents to dive into that with both the pit supervisors and the dispatch supervisors and try and find an understanding of what's gone wrong. It also allows us, if we blow that time period out, to track a trend over some time. And this is certainly something that we've worked on hard over the last 12 months to drive a positive improvement. When you see something like this, you should be starting to ask questions and go, well, what are some of the factors that delve into shift variation? Now, an absolute outlier like that 28%, something's gone wrong. There's something happened on that crew or that shift that's gone wrong on that circuit, whether it be an intersection change or a truck breakdown or something along those lines. But the biggest thing or the biggest trend that, we've established that contributes to haul cycle variation is actually operators. So I flipped onto another slide, and this is the subsequent dashboard that initial one got us to create. So about 12 months ago, we created the top view you can see on your screen now, which is an operator box and whisker. On the left-hand side are operators whose average, or mean, if you like, shift or haul cycle variation is quite low. In other words, their variation is small and they're generally fast. So that green line that you can see running across there, that's the average. So that's the average, variation and speed for a haul cycle. This is a pretty complicated and clever graph. It's comparing apples with apples. So it's comparing operators who've had, a certain amount of training, a certain amount of loads in the data period or in the time period that it's set from, and it's only comparing like cycles with like cycles. So 12 months ago, you can see we had quite a large spread between our fastest operators and our slowest operators. And we also, all our operators, even our fastest operators, had a real variation or a lot of variability in their haul cycle between their fastest and their slowest. And then, you look at their outliers too, which were all over the shop. Drop down, fast forward 12 months. Now, out of the actions that we've created from that top screen, which is more than anything, it's been picking operators who are in the back half of that graph and mentoring them. So putting trainers in the cab with them and mentoring them about how they can be more consistent, how they can pick up their cycle time. And then even for the better guys, it's just showing them, deleting every other name and only showing their name and just showing them, this is where you fit. You're in the mid pack. If you're looking for progression in your career and upskilling, you need to get in the top 25%. You can see 12 months later on that lower slide, we've driven a drastic change. So you're still going to have 50% of your operators better than average, roughly 50% not as good as average. However, you notice that it's a lot flatter and there's a lot more operators clustered around that mid pack. You also notice that the variation, even the variation between some of the lesser operators, but particularly, say, the top 75%, which are people who are experienced, they're not trainees, but they haven't just been here 5 minutes, that variation has tightened up something chronic. And that's due to the sustained effort that this data has enabled us to put into individuals and train them. The other thing we'll notice is the data doesn't show what the mean shift performance is doing. And I can 100% guarantee that our shifts are getting bigger. We've added more dig units, more haul units, more operators, and both our raw production and our productivity on the shifts has improved, quite a lot and increased. So again, it's just more cream or more, efficiency that we're using Avoca to cream out of or drive out of our system. The next couple of slides I'm going to show you doesn't look like Avoca at all, and that's because it's firmly some graphs and charts made in Excel. So I'm looking here at waste, actual performance versus forecast performance, coal, waste. I'm going to flick through to the next slide, showing you some graphs and charts that come out of Excel. The reason I'm flicking through those two things and showing you is I thought it was worth to show you what we're doing next in Avoca. So this is currently an Excel document where we've got an engineer who we're paying, I reckon it's taking him about 12 hours, which is a day and a half of his week, to create this analysis in Excel. And that is looking for data, then entering the data into an Excel model that he's created, and then presenting it to myself and the rest of the management team for analysis every week. So we've just purchased a few extra Avoca licenses, and like I said, have committed to it for the life of mine. And part of that is to give this engineer who's created this, who's our dumps and haulage engineer, the ability to build this report as an interactive dashboard in Avoca, so he doesn't have to do the data entry. That's going to mean that instead of paying him 12 hours a week to do data entry and try and create this data for myself and the management team to scrutinise and see how we went according to our plan, we're going to be paying him to run this report on a Friday morning and spend his hours, and probably only give him half a day to go through and provide analysis. So he'll be able to see what we've done, see how we've compared against forecast, it's the agile plan and actual, and then dive into it and provide analysis. So when we walk into our Friday management review meeting for the week that was, instead of us sitting around a table in that meeting and trying to review it, we'll sit there with the data and the engineers considered analysis of what went wrong, so we can quickly provide actions to come out with that. That's really the value, more than anything we're driving out of Avoca. It's the same if I flick back to this box and whisker plot on horse cycle variability. One of our engineers built this in Excel, built a way to measure this data and compare operators, but every time we wanted him to run this report, it took about 3 days for him to modify the model, enter the data, after finding it all and putting it together. So why are we paying an engineer to do that for 3 days? It means we're going to do it once or twice a year, but now it takes 30 seconds to run on Avoca, after 1 3-day build period from the engineer. That's the advantage we're driving out of this, and there's some quite real positive benefits and cost savings for our business. And more than anything, it's about creating mental headspace for management and your engineering or business improvement team to do what you're paying them for, as opposed to being data entry clerks.